In just a couple of years from now, humans will return to the surface of the moon. We're going to see astronauts from NASA as well, potentially as astronauts from the Chinese Space Agency set foot on the moon. Who knows? Maybe private companies will also send humans to the moon. And when they do, they're going to need spacesuits. They're going to need to be able to go out onto the surface of the moon. And it's not just floating around in weightlessness like we have on the International Space Station. They're going to be crunching through the regolith. They're going to be avoiding rocks. They're going to be trying to set up a larger facility so that people can live on the moon for long periods of time. And that means robots. They're going to need robots to be able to extract resources, to be able to manufacture and provide structures and raw resources like water ice for breathing and rocket propulsion and so on. And so when you think about a human being walking out on the moon, they're going to be surrounded by an army of these robots. They need to know where these robots are. They need to make sure that they can navigate around as they are the conductor of this orchestra of robots and stay safe. And so not only will we require a different kind of spacesuit, but we're going to require a different way of interacting with our environment, our robotic environment around us. So my guest today has been thinking a lot about this. Her name is Dr. Yang Gao. She is a professor of robotics at King's College London. She's been doing a lot of thinking about what would a spacesuit of the future for a lunar explorer have to work like to interact with this robotic infrastructure. And we talk about just like how our understanding of robots today is going to have to change. What are the constraints that you have to deal with in the lunar environment? What are the lessons that we can learn from the moon that we can bring back here on Earth? And, humanity is going through this very interesting transition where we go from humans doing knowledge work jobs and physical jobs, maybe to this future where a lot of artificial intelligence is taking over some of the knowledge work jobs and the physical jobs simultaneously. And it's going to be an interesting time. And then what impact does all of this computation and technology have on both our environment here, as well as sort of sustainability in a lunar environment where precious resources are very limited? So it's a wide-ranging conversation about robotics and artificial intelligence and machine learning and in situ resource utilization. So enjoy this conversation with Dr. Yang Gao, professor of robotics at King's College London. Dr. Gao, let's imagine we're a few decades into the future and an astronaut is at the lunar research station and is walking out onto the surface of the moon, but is better equipped for the lunar environment. Give me a sense of what we might see their equipment looking like as they set out onto the surface of the moon.
Sure. Looking into the future, I think it's certainly envisaging a co-working between human astronauts and robotic machines as a team in terms of performing sustainable operations on a lunar base. And you could be looking at the surveying task of the lunar surface to be shared between the robotic machines in terms of rovers or different robotic tools together with human astronauts. You could be looking at construction work, maintenance work of infrastructures on the moon base to be principally carried out by robots under human supervision.
So are you is it a standard? I mean, we think about the Apollo moon suits that the astronauts wore, and they were different than the kinds of suits that we're very familiar with for, say, outside of the International Space Station. Do you, and you mentioned in your recent article that there's work right now being done by Polaris and others to develop a lunar-oriented space suit. Based on sort of what we know today, I guess I'm asking, what does it sort of look like based on our understanding and the sort of the more complex requirements that they're going to have to be on the moon?
I think what we're talking about looking at the future human spaceflight is the introduction of more technology and innovation into things like the spacesuit. Looking at how to enhance the capability of human operation in conjunction with robots, we are looking at potential wearable technologies, Internet of Things through those connected sensors to be embedded on future spacesuit that can enhance the situational awareness capability for human to operate in outer space or hazardous environment. Because this kind of inspirational missions carried out by the private sector, we're seeing the extension of human spaceflight into individuals, which are ordinary citizens. They're not necessarily very well trained, particularly physical, in terms of physical capability. And we are talking about ordinary people to be, potential space citizens in the future. Therefore, the use of robotic machines, intelligent systems to assist them in such an extreme environment, it become very necessary and critical. So we're talking about those technologies to be introduced to achieve that.
So, what do you envision as a requirement for situational awareness? What will a person out on the surface of the moon need to know about their environment?
Because in extreme environments such as space, we know the human physical capability tend to be hindered because of the extreme environment, the environment we're not very used to or feel comfortable with. Therefore, you need additional sensoring capabilities to help kind of meet those gaps, such as even visually, we could have sensors that built into the hammer of the part of the spacesuit to help enhance the visibility of the environment. We can build in sensors to detect environmental parameters, simple things as temperature, simple things as how the human body react in the environment, those biosensing data, so that the human could actually in real time very promptly, be informed about what is going on externally, but also within the human body itself. And also we talk about co-working with machines that has mobility, machines has some level of intelligence on board. And again, being aware of what's going on in that robotic partner, that co-worker, is another, I think very important data to be made aware by the human.
I can imagine you're out there on the surface of the moon and trucks are rumbling by and robotic arms are sintering regolith to make walls and roads and things like that. There's a lot of moving parts that you're trying to be a conductor for this orchestra of robots, and to know where they are and to know to not get yourself hurt sounds pretty important.
Absolutely, the safety is, I think, the priority. Uh, I I think a lot of technologies that has been developed always consider safety operation being the baseline. So anything you add on top is just enhance the performance. So in this scenario, I think in the technology or innovation we've been talking about in terms of wearable technology, Internet of Things in space, enhancing the situational awareness, is all basically need to ensure the safety operation of the human and also the collective, kind of team of effort. There's also things that we've been very heavily looking at in line with this idea is to look at when we introduce machine learning, artificial intelligence to improve the machine intelligence, we need to be considering the robustness of the algorithm we introduce. We need to think about the trustworthiness of those more intelligent functions we embed in machines that need to work with human in a very safely manner.
Right. I can imagine you don't want your robot assistant hallucinating beside you while you're attempting to get some work done. So I want to understand, like, right now, spacesuits and sort of the exploration on the International Space Station, it is a weightless environment. They put on their spacesuits. They've trained in neutral buoyancy tanks. They go outside. They attach various modules and so on, then do maintenance work on the outside of the International Space Station. But it is complicated, but also it's kind of simple because you don't have to deal with all of this weight. There's no lunar regolith to deal with and so on. There is a robot arm, a proudly built Canadian robot arm that's helping. But on the moon, especially in the beginning, there's going to be a lot of very physically demanding construction work that's going to be required. How do you think that changes the sort of the requirements regime for the kinds of spacesuits that astronauts are going to need to wear?
I think spacesuit is a good example to kind of help showcase the difference in the requirements, whereby in the moon case, I think to begin, you're probably looking at the unstructured environment compared to the International Space Station, because the ISS at the moment, I think you can probably assume it's largely a structured environment because you build the infrastructure, you have all the design that comes with the original construction of
Right. The
the
handholds are in the right places that you
yes.
need as you
So
move around the outside.
yeah, so you have a lot of knowns. Well, with a lunar base to start, I would say particularly at the beginning, you probably have to assume it's an unstructured environment. In terms of dynamically changing features, I would say it's probably also more compared to the ISS scenario in orbit. So in terms of the human involvement, I think you might want to ensure at the start that the spacesuits enable the astronaut to be very functionally successful in terms of supervising the robots to do most of the task. So keep yourself from a safe distance to begin. But I think as they move forward, I think the partnership in terms of shared autonomy could probably slightly shift. But I think from a safety point of view, you want maybe the human involvement to be more kind of in the background, will successfully supervise or instruct the robot to carry out most of the heavy lifting task.
One of the problems with the moon is that it's incredibly expensive to send stuff from Earth to the moon. Right now, millions of dollars per kilogram. Hopefully this cost will come down, but they're not going to come down a lot. And so it makes a ton of sense to use resources on the moon for the moon, such as the reserves of water ice, the regolith for building materials and things like that. And so I think that shifts that transition from, say, the space station being this, as you say, the structured environment, that very known environment. If you're going to rely on local resources, you're going to need to deal with an unfamiliar, unpredictable environment. There could be a avalanche as you're digging at the side of the permanently shadowed, crater to extract the water ice. There's dangers. And yet that's probably still more economical to extract those resources locally. So do you think about that sort of like, what is that balance between providing a very safe environment versus the necessity to live off the land, and how robots will play a role in that?
Yeah, I certainly agree. In situ resource utilization is probably the right route moving forward in terms of construction or establishing or maintaining a lunar base. I certainly believe you need to largely rely on resources in situ rather than transporting that from Earth. Also from a sustainability point of view, that I think makes a lot of sense. Because of that, I think it is almost being recognized collectively by the space community that you need more autonomous robotic systems to help, perform, first of all, the surveying of the resources, identify their locations, and are followed by, explore more exploration, and also I think some very serious robotic activities that direct engage with the local lunar regulars or some of the land features. It could be a crater, should be a cage, potentially a lava tube type of landscape, and using robotic machines to exploit the local resources. And you need to also figuring out technologies that can perform potentially 3D printing locally, and then followed by further infrastructure construction. I think that whole process, at least based on our current understanding, knowledge, and consensus, it will involve largely autonomous operation, semi-autonomous operation by robotic systems.
So give me a sense of, you talk about this like largely autonomous. So help me understand this. How the astronaut is there, presses a button, the robots head out onto the landscape. What do you sort of imagine is going to be happening from a kind of coordination
Mm.
perspective?
Sure. I think when it comes to this type of large scale operation, we're indeed looking at a level of autonomy at different phases. It could involve at some point remote operation, from the astronaut in situ to a robotic system from a distance, move on to we call automation, meaning there's a decision and plan being made ahead of time. There's a press of button where the robot just executing this predefined decisions, and then moving on to semi-autonomous or fully autonomous operation, whereby you could be looking at a scenario where, say, there's this, cave in on the moon in a permanent shadowed area in the crater, not explored before, the lot unknowns. What you might want to provide instruction to the robot is to say, look, I'm giving you certain period of time. Okay, this is the energy you're available on board before you can next recharge. And I want you to go there and make exploration and come back and give me some data. So in that task, what I want you, the robot, to do is to explore as large area as possible in that cave or permanent shadow region. Giving that top level mission goal, the robot can go in, make decisions itself, of various subtasks. So you can consider that being autonomous or semi-autonomous operation. So I think it will be a combination of a range of autonomy involved.
Right, right. I can imagine. So you tell the robot, go in, explore, map out as much of that region as you can, and the robot goes in and it sees rocks and it moves around them and maps them and sets them as potential hazards for future robots, and then comes back and hands over the map when the job's done, as opposed to, I mean, right now, I mean, people don't realize, even say with the Mars rovers, how intensive the process is. There are Mars rover drivers who look at the landscape in front and they say, you're going to move forward this many centimeters, then you're going to turn, then you're going to move forward, then you're going to turn, then you're going to examine this rock at exactly this location. And the robot is just carrying out the instructions. But that does not scale when you need to build a lunar facility.
Yeah, I think it is very true with some of the state-of-the-art technology. We still very often prefer some kind of remote operation purely for the safety. Because we talk about Mars, we know there's some geological features on Mars, such as something called dual cross, which look flat and safe and solid, but when the rover moves on top, they sink because that uniqueness of the geological behavior. So similarly on the moon, there might be, similar terrain conditions which might look safe on the surface, but it's not actually safe when the robots move on top. So that's why there are a lot of unknowns, on structure and dynamical behaviors in outer space that we, unfortunately, we don't yet have the full knowledge of. So I think for the safety of machines as well as human in space, we sometimes has to be kind of, quite prudent. I think that's why having a full range of operational mode where you can move across the different operational kind of settings. Sometimes if you don't feel very confident about the novelty in the environment, you rather choose to be, more conservative and saying that let's remotely control it slowly. Well, in areas that maybe you visited before, you could say, yeah, I just want to take more visits and increase, say, the resolution of the data collected from before. Then you can be a little bit more courageous and use more autonomous. And there are also areas that we know it's not possible to remotely operate because the direct communication link is not feasible.
Like in
There,
one of these lava tubes.
exactly,
Yeah.
there blockage of the direct communication link, or maybe the power constraints doesn't really make it feasible for direct link communication. So you somehow has to compromise. I think one thing that happens all the time with space operation is that it's a trade-off. You
Hmm,
have to
hmm.
prioritize and what's important and make decision based on the trade-off.
We're seeing quite impressive growth in robotics, especially with this idea of letting robots live in simulations and then, using large language models to give them tasks, pick up the red apple, put it in the green drawer, and they practice these things in simulation, and then they go and live in the real world. So what image generation and text generation has happened so far, we're now about to see this revolution in embodied large language models, as it were. Do you think, as this exponential growth continues on, do you think that fundamentally changes what role robots are going to be playing in these space environments? Are we imagining correctly what the future looks like?
I would say in the long term, yes. I think it does have a significant impact because somehow in our research, we also look at training through demonstrations. because there are a lot of historical data coming from space missions, which probably has been underutilized so far. So with all, I think this advances in machine learning, I think we are also, get inspired by some of those discoveries and see how much we can take advantage of that and use that for advancing space technology. So I think in the long term, definitely there's a positive contribution of those discovery. But perhaps what you see slight difference with the space technology developments, at least this is my personal experience, is that maybe the pace of incorporating that maybe is relatively slower compared to some other sectors, because I think space always had, I think for very good reasons, that has rigorous processes in the space mission analysis and design, and so does all the spacecraft technologies. So it always goes through an iterative process, design process, so that you're fully aware of what the progress I'm making with respect to the reference point, rather than just randomly pick and choose different things. Then you don't know exactly what is making the impact and in what way it is making the impact. So I think that's a good thing. So to introduce uh, new technology into the space framework, I think it is ongoing. We are also looking at extensively potential utilization of machine learning or deep learning using neural network, and see how we can better model the dynamic behaviors in the space environment that can be used for either navigation control of spacecraft or better interpretation of the space environment that can be used by both robots and astronauts. So those are ongoing. We're definitely traveling in that direction. But I think in a way we're doing it quite rigorously and still use the space system uh, designed development templates.
Right. I mean, I think about all of those constraints about you want the hardware that's flying to space to be, you know, that it's going to work in a space environment, that the computer is hardened to be able to deal with radiation, that the components have all been tested in space in the future, and that limits the amount of memory that you're going to be able to put on board the robot, and then that limits the intelligence that you can try to put into it. And it's one thing, I guess, to have racks of A100 chips that are running some robot that's scampering around a obstacle course on Earth, and very different to have some version of this that is out on the surface of the moon attempting to navigate this environment using what in some cases is going to be 20-year-old technology to be able to still get the job done.
You're right. The computational, capability or computational limit of modern spacecraft has always been a issue. I think it's a limitation of how much maybe machine learning we can potentially apply to space systems, particularly in the space extreme environment. I think that is indeed a practical issue. But at the same time, I would argue that that constraint at the same time provide a good opportunity for novel research, because I would argue that the we classically refer as machine learning or intelligent software, they don't necessarily have to work in high computational environment. I know it has been the environment they've been tested on and proven to be quite advantageous, just because the application that has happened to be used. But I would argue that, the computational intelligence, if you think about it, is also something we learn from biological system. Just like some of the locomotion mechanisms we learn from animals, insects, I would argue that a lot of this very interesting things we observe from nature, either computationally or in terms of in the physical mechanism, I would argue they've been evolved over time. Also with constraints sometimes of mass, volume, and power. So it might be that when we learn from nature, we might only try to capture, one aspect of its strengths. But I would argue as our knowledge proceeds, we study deeper into the techniques or technologies that we try to capture from nature. I would argue that we will find solutions, even on the algorithmic side that can work with limited computations, or maybe computations that is more efficient or optimized. So so I have a lot of hope on that, and in fact, a lot of my research is very focused around that, looking at algorithmic development that can really perform very efficiently given the computational constraints we have in spacecraft and how far we can push the boundary. Or I would often say, we basic research and try to identify if there are limits, or if, and where the limits are.
Right, but it's like hard coding instincts into your robots versus having them learn, which is a more complicated, more energy intensive, memory intensive process. That if you pre-program certain capabilities right onto the chip itself, then that simplifies the complexity of the job. So I'm fascinated with this idea of self-replication. When are we going to be able to, or are there any kind of enabling technologies that will move us towards robots being able to maintain or even duplicate themselves?
When you say duplication, do you mean physically or
Yeah,
only
physically,
Mhm.
obviously there are certain parts, like you're not going to build a chip fab on the moon, but there are local resources that you can build structural elements for your robot if you need it. You could build an exoskeleton, you could sinter regolith, 3D sinter regolith. In fact, the Chinese Space Agency is planning for the Chang'e 8 mission, I think. They're planning a 3D printer on the moon that's expected to pump out parts at some volume per minute or something. So I think there's the idea of like, can we construct parts and components? And so, like, what if the robot is really just the controller and a few basic parts and it's able to build its exoskeleton? I don't know, like a hermit crab or something.
Mm. Yeah, this is a very forward-looking idea. It is very true that some of the building blocks to achieve this has been kind of gradually, systematically tested. For example, 3D printing being one of the underpinning technology has been tested in some of the previous Chinese missions. I think this is a very valid application moving forward. I mean, this linked back to what we discussed earlier regarding in situ resource utilization. I think fabrication, manufacturing, additive manufacturing technologies that combined with some material science is those key components to achieve this kind of very forward-looking application ideas. Yes, I certainly can see this in the long term will be very beneficial. I think perhaps also from an environmental sustainability point of view, this really would be a good solution moving forward.
Right. You minimize the amount of cargo that you have to take to the moon, the drag on the resources here on Earth. And yet, I mean, you can imagine some far future where you send one robot and then it just starts making copies of itself on the surface of the moon or on the surface of Mars or some asteroid or whatever. And then you can fulfill whatever application you want. You just have to wait for the robots to build up enough number to get the job done. And then, I don't know, dismantle themselves when they're done or something. I don't know, it sounds kind of mean.
I think it is very true that shift of the manufacturing from Earth into space, I think is, in terms of long term, is a trend because it's I think in addition to saving launch cost, but also saving some of the environmental impact by the manufacturing and maintaining the facility on Earth itself is also a big saving in terms of carbon emission. So yeah, absolutely.
Yeah, I have this sort of theory, and I'm sort of waiting to sort of watch it play out. But I think that as the robotics get better, and as our capability to build and maintain structures and infrastructure and facilities and stuff in space out of local resources where they're needed, our need to launch mass off of planet Earth goes down and down and down. And so right now people are sort of imagining this dystopian future with hundreds of SpaceX starships taking off every day, belching methane into the atmosphere to drop stuff on the moon. But I can imagine a future where one takes off every month and it has a bunch of humans on board and they're all holding a bunch of microchips. And then it meets up with the lunar base, and that's it. And everything else is grown there on the moon, and everything is supplied from the moon. And they bring in the fresh supplies, the medicine, and the microchips, and so you don't need to launch a lot of mass off of the Earth. It's all done in space, and it's the robotics that make that future possible. And we may get to a future where very few rockets launch because we don't need them.
I think that certainly would be, from the environmental sustainability point of view, would be ideal.
Mm-hmm.
Of course, there are also discussions along the line of economical sustainability, social sustainability. So I think there are a lot of discussions around that in terms of what we really want to be robots for to achieve sustainability from all these different aspects. But I agree. I think environmentally, if the capability of manufacturing in space can be accomplished to a degree, it's economically sustainable, then definitely, I think that's the future direction.
So, Dr. Gao, what are you obsessed with right now?
Well, I'm very loyal to space robotics research. So my focus, I think, now is more moving towards how to achieve sustainability in the robotics design development itself. So we know robotics is perceived as a solution to a lot of sustainable space applications in the long term. Examples we discussed earlier. But I think within the robotics design development itself, I think we want to ensure that future solutions we offer are also sustainable. It's basically environmentally sound. So things we design, develop in the future, from the kind of hardware point of view, it should be healthy and environmentally good for the outer space. The software, the intelligence we embed in those machines, we want to ensure they are safe to use. They're they're explainable. They are trustworthy as part of the ecosystem. So those are my key focuses now. I think we're in my view, that we're advancing from just focusing on pushing the performance of those systems into something, I think, a more responsible perspective.
Yeah, it's really hard to think about. I mean, you see some of these demos that people are doing, like Boston Dynamics and NVIDIA. They're demonstrating these robots, and their growth and their capability is advancing at a accelerating rate. And then you think about, yeah, wouldn't it be great if you had a robot that was in your house that was washing your dishes, I don't know, or whatever, cleaning up after you. But does that mean that there are hundreds of millions of these robots? What are the environmental costs? What are the social costs that we're going to that this is going to come at us very quickly, and we are not ready. And then you think about all the other ethical issues. Do you put them on the battlefield? Do you let them? I mean, we are attempting to, while we're in the midst of attempting to digest artificial intelligence as a brand new sort of complexity, embodied artificial intelligence is a whole other thing that we just haven't even thought about grappling with, both on how it changes our culture and our society, but also, as you say, the resources that are required to build these things is a pretty heavy draw on the environment.
It is indeed. I think on the positive side, as from what my observation, working in the robotics community as well as the space community, I see there's a growing kind of recognition that, while we're developing advanced technology, we need to be equally focused on their impacts. The impacts come from environmental impact, social impact, economical impacts. I think going back to the keywords we've been basically discussing around the sustainability, I think it's something the community as a whole, I see we're recognizing this being an issue. Also, take my own work as example. Well, I was very passionate developing the technologies for making robots autonomous, very capable. I'm also seeing a bottleneck sometimes where you make these machines very capable, but you also start to see resistance of them potentially being deployed because we don't fully understand, all the necessities within the technology itself in a way that we feel we can understand by having a human there. So all those, should we say, the challenges make me think very, very clearly that we need to have the discussions around sustainability and probably embed the design relating to sustainabilities in the core of the research, not as afterthoughts. Very often you cannot design the technical side without thinking much about, what is the impact of it. But instead, I think in the future, what personally I'm currently promoting is that we will introduce those design features relating to sustainability from the very beginning of the research. Actually, it's doable. You can capture some of those concerns within the actual research itself, within the design itself. Then what you can then demonstrate is a solution would have already considered the sustainability concerns. So that's something I'm actively working on at this moment. I know it's still a long way to go, but I'm quite optimistic and hopeful about it.
I mean, even just in the last couple of years, we've seen the energy consumption used by computers go up dramatically, and that it's it's now as much as various nations and is continuing on that exponential curve. And when you think about the computation that's going to be required in each one of these robots that are doing all of these tasks, it's a huge load. And then at the same time that we are facing, when you think about the wrenching changes that happened during the Industrial Revolution, we are facing a transition both on the sort of intellectual jobs world, thanks to artificial intelligence and machine learning. And then people are like, well, don't be a computer programmer anymore, be a plumber. Oh, well, no, wait, the robots are coming for the plumbing jobs as well. So it's a tough time to both deal with these two wrenching changes that are going to happen to our society, and also think about how we minimize the impact on the environment as we move forward at a time when that's one of the most important things that we have to face. So it's going to be a tricky time, and I hope robots will save us all. I mean, that'll be the solution. Well, Dr. Gao, it was a pleasure to talk to you. Thank you so much for chatting with me, and good luck with, I guess, orchestrating a bunch of robots on the moon to help explore and build a lunar base.
Thank you, Fraser. Thank you for inviting me. All the best.
Bye.
Bye-bye.
I hope you enjoyed that interview with Dr. Gao. I'm going to thank my patrons and then give you some final thoughts. A special thanks to Abe Kingston, Andrew Gross, Antonio Lofilara, David Gillinan, Dougie Stewart, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Mark Anstis, Paul Rohrbach, Stephen Krasaki, Stephen Feiler-Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. I think if we went back 10 years and you told me what the future of artificial intelligence and robotics was going to look like, I would think you were crazy. That's maybe eventually, but not in 10 years. And yet every day as I read the news, as I sort of learn about what kinds of advances are happening, this stuff is coming very, very quickly. And I think we so far have really not thought about the consequences. The good consequences about, I want that robot washing my dishes, please. That would be amazing. But also the bad consequences about what is the impact on the environment of all this additional computing, as well as the resource extraction to build these things. And then just what is the implications on the job market. And then at the same time, I'm really excited about how this level of automation brings forward that science fiction future that we have always been anticipating. I think the way we get to that future of humanity in space, ironically, is not with humans, but with robots, with self-replicating robots, building the infrastructure in space that allows humanity to live in this really extreme environment. We can't live there today. We need heat and cooling and power and food and other resources, and there is just none of it out there in space without us building something first. Until when we send the robots, they will do the hard work. And so robots are going to be key to this whole process. And I'm really looking forward to, with fear, at how quickly all of this is increasing. Now, I've done other interviews on this subject about building self-replicating robots on the moon. So why don't you check that out? All right, we'll see you next time.